All right, guys. So, part 2 of lesson 16 today.
Yay!
So, number 6 and 7 just asked us to be on VMware and do the pie chart and the bar graph. So if we want to do that, and then
What does
someone
it
can
mean by label it?
Sound great?
Okay. Do we have to label it like a very tricky way, or like how do we label the pie chart?
So label it, it said that just to label the
ranks.
Yeah, like the colors. So like when you do the colors, you just make sure that that you do click the labeling, that you label it by rank.
Okay.
So, and then on the bar graph, it will do that automatically. With the pie graph, it will just show like a little thing in the corner with like the colors and then like rank.
So do I have to do anything with that, or is it just
No. It will just show up automatically.
Okay, got it. Yeah.
I can show those too if you guys want. Like,
You can do what?
I was doing my homework and I kind of did some of what we were doing today.
Oh. That's good.
I usually have to do that.
Yeah, that's helpful. Extra practice.
Okay, I'll put it on screensaver. There we go. Okay, so there's my pie chart for all y'all.
Yay, that's what mine looks like. Cool beans.
Let me see.
So much rejoicing.
Can you show me your pie chart again?
Yeah, go back up.
Okay, yeah, that's mine too.
Yay.
Okay.
Alright.
So you put rank in the category, right?
Then when you guys are ready for the bar graph, I'll show you what I got. I had to figure out why the heck it was showing me that right there. And I was like,
What is that? I have that too.
it's people who aren't in school. And I'm assuming this is college almost.
Yeah.
Because it's like people who haven't gone to college who they survey, who have jobs.
I guess so.
Or something, or I don't know.
Yeah.
There were like so many different variables on that one. I was like, I don't even know right now.
All right. Are we doing number 8 together?
Number 8, yes, we are doing that one. Because I actually don't. Sorry, it says 9 on mine, but it should be 8, but this doesn't delete.
Okay.
Oh,
I have the same thing sometimes.
Okay, I'll stop. There you go. Yeah. So after you guys have gotten your pie chart and your bar graph done, then Brianna, do you want to do number 9?
Yes.
After that? Okay.
So when this says use at least?
Yeah.
Use at least.
So when everyone's ready. Did everyone get it done?
I use at least 5 descriptors.
All right. Okay, Brianna.
Okay. Use at least 5 descriptors to describe the data above. What does that mean?
Yeah.
So just like general stuff, like there's more sophomores.
Yeah, there's more sophomore. That's what I was thinking. I actually didn't know.
Yeah.
On it, so I was like, what do they mean at least 5 descriptors to describe the data?
Neat. Yeah, I guess just like rank them. I don't know.
So there's more. The most is sophomores. Sort of thing. Okay.
Yeah.
So it would have 4 or more different labels.
Okay.
Is that right?
I
Counted people that weren't in school?
yeah, I guess we count them.
Yeah, the last label I think is people who aren't in school.
So SO is senior, right? No. Sophomore.
Yeah. Oh, wait, let me see. Yeah, sophomore then SR is senior.
Freshman.
Okay.
So
We'll see if that's right.
then we were right, there are more sophomores than any other group. There are people who aren't in school is the smallest group.
That,
Yeah.
That's the oh.
Right.
You know, could say, let's see, like there's, I don't know. I don't know what exactly he's looking for. Like there's twice as many sophomores as seniors. Like the proportion of that looks like it's almost double.
I'm wondering like what it is about gender handle, flip, link, skills. Yeah, I guess it is just based on that.
More sophomores than anybody.
Okay, so I have 3 so far.
3 what?
Descriptors. Are there 2 other ones?
Is that what you guys are doing? I was doing it really simple.
Wait, what was it that you were doing?
I just put that like the most with sophomores and then next is juniors, next.
Oh, is that what you can do?
I don't think I'm right. I was just getting.
Those descriptors?
I don't know.
I thought those were descriptors.
I looked in the reading and it didn't have anything like that.
Yeah, that's what I'm just winging it, but.
I don't know.
Abstracts were enough. Checked for new results. Irrelevant results.
I wonder if it means like mean or anything like that. Because would they want to see it the mean?
Yeah, that's what I was wondering, but I was like, based on the graph, I can't tell.
Yeah.
Oh,
Well, what'd you look at?
But like, so I put there almost twice as many sophomores as seniors for one of them, and then it looks like there you could say there are about 3 or 4, I don't know, as many seniors as freshmen.
Ah.
I don't know if it's 3 or 4. What do you guys think? 4?
Let me see.
Yeah, I'd have to say 4. There's a lot more.
I'd almost say like 1, 2, 3. That's like a lot. More than
15 freshmen.
15 freshmen. Ooh.
I'm just estimating. Or less.
Oh, you know what we can do? We can actually get the percentages on this. I remember watching that in the video.
Ah.
Yeah. So if that helps at all, that might.
60% juniors.
Yeah, that's where Lori's getting that from, huh? Okay.
John, can you get her?
About 75% sophomores.
I don't know how he did it. Goodness, it on here. Probably.
Well, that's a count, so it's probably 70 sophomores, 70. Because it says count on the side.
Oh, okay.
So 40 seniors.
I don't know.
And 2 not going to school.
Lori, how did you get the percentages?
I'm gonna go to the bathroom really quick, guys.
Oh, I didn't do percentages. I was calling it percentages, but it says count on the side.
Oh, that's what that's what you mean on the actual data. Okay.
I don't know how you guys are doing it.
I don't know how to do it.
I don't either. I just saw him do it on the video.
I'd have to look at the video again. Freshman 10. 60 junior, 70 sophomore, 75 sophomore, and 40 senior. Chart.
Okay. Are we on number 10 now?
Yeah.
We can be. Oh, you guys finished? You guys finished 9?
I just went to the
Well,
bathroom.
no. Just kidding. I'm on number 9.
You are on
I think
number 2?
There is no number
7% of the true unknown percent of population do not have a traditional phones, instead rely on cell phones. 7% is P. Suppose the random sample of 750 telephone users is obtained. What is the probability that more than 60 phone users, 8% on the survey, use only cell phones?
Okay, got it.
Calculate the mean and standard deviation of the sampling distribution based on 750 phone users. So you set up the mean by doing x over n.
Yeah. Yeah, so it's 8% for P-bar. Or,
So you do 7% or
Yeah, I think 7% is the. I don't know.
10. Is P the mean?
Yeah,
that's
because
like the population mean is 7% and the sampling distribution mean is 8%.
Okay.
so x becomes 60
Yep.
and n becomes 750. And then you divide.
So standard
And then you do the standard deviation, which you set up as the square root of p, parentheses 1 minus p, parentheses close over n. Says it's 60 times 1 minus 60 over 750? Or not?
C.
The standard deviation of P hat is P times 1 minus P divided by N. So it would be like 0.07 times 1 minus 0.07 divided by 750, I think. Or is it 60?
Mm-hmm.
It's divided by 60.
Oh, that's where I went wrong. Okay, I did by 750.
So what we divided by 750?
Yeah, I think it's 750 because it's N. Yeah.
Mm-hmm.
What's the probability that more than 60 phone users in the survey only use cell phones? And then that's when we use, that's the number we use in there.
So when you guys did the standard deviation, did you get like a really small number?
Yes.
I got 0.0093.
0.0093?
Yeah.
Okay, let me do it one more time. Because I got like even smaller than that. So I get like 0.0000.
Oh, Kaylee, are you getting the square root of them? Of it all?
Ah! Ah!
I just thought of that.
It makes perfect sense. And then I'm like, oh, that is so small. I don't even know how I'm doing that.
Hang on just a second.
0093. Here we go.
Bye, Mama. Have a good day. Okay.
Alright, so we got all of that together. Now what about, so we all got, so P bar or P hat, sorry, is 0.08. And then the standard deviation of P hat is 0.0093, right?
993?
I just got 0.0093.
0.0093. But something close to that. It's 0.009 generally. But then B, Hannah, do you want to do B?
Yeah, state the problem in terms of the variable. I don't know.
In terms of the variable. Okay.
So P hat. Aren't you going back to X over N? I don't understand what the difference is.
Yeah, I don't know what it's asking either.
Oh, okay. So I think I might have a little thought here. So the formula for P hat is X over N.
Okay. So earlier when we used it as a mean, what was the mean formula?
The mean is just kind of like, do you remember back in the day whenever it was like population mu, they're like, what is the mean? And you just assume it's the population mean. I think it's the same for proportions. So
P is like 60?
I put 7% is because it said 7% is P, which is the population proportion. So.
Okay.
Okay, guys, and I looked over the answer really quick for A. So yeah, P equals 0.07 because it is, I guess it is asking us what the mean, so just like X or mu is, so it would be 0.07.
Okay.
And then
Good to know.
B is, it's just P hat. Yeah, it's X over N or 0.08. So this is really confusing.
It's just 0.08. It's not anything, it's not over N?
Or you can do 60 divided by 750 is what it says.
Oh, okay, and that would give you that percentage.
Yeah, it's like, because in the parentheses it says P hat is greater than 0.08 or 60 divided by 750.
My hand is itchy. Okay.
And then, Brianna, did you want to kind of do C-ish, maybe?
So what was B?
So B is 0.08.
How?
Yeah, is greater than 0.08.
How did you guys get that? Was it like a formula, or does that just from the problem?
Well, p-hat formula is x over n, so I'm assuming you take 60 over 750, but I didn't do the calculations, so I don't know if that's right or not.
Yeah, no, that's correct. That's correct. Sorry.
Oh, and then it's 0.0. Okay, got it. Okay. X divided by... Okay, now we'll do the next one. So, draw a picture, the normal curve, and shade the desired area. So that's just an applet, right?
Yeah.
Or no?
I would think it would just be an applet, isn't it?
We would have to get the z-score first, then, right?
Yeah.
Or no?
Yes.
So you do z-score with value minus mean over standard deviation.
But then why would it have us do it in D? So maybe it's something different.
Yeah, it says like you should have a normal curve with the area to the right shaded. This is just conceptual since you won't actually compute the z-score. So pretty much I just did this. I just went to this.
Alright, I'll just save this then.
I did it on a card.
Very nice, very nice.
There's this little unshaded spot right there, and that's about it. I don't know. Okay, and then I'll do D, I guess. So
Okay.
convert, standardize the values of p hat using the standard normal variable z. Find the z-score. Okay. So z-score is p hat minus p divided by the square root, which we determined previously in A.
So p-hat is
0.08 minus
0.08 minus 0.07.
And then you divide it by 0.00931-ish, you know, that sort of stuff. And then you get, come on, magic calculator. Okay, so I got for z-score 1.07. Whoop, 7. 0.74. Did anyone else get that?
Yeah, I got 1.075. I divided by 0.0093. Did you do 931?
Yeah, 931. Yeah.
So, yeah.
Okay, yeah, similar, so that'll work.
So then,
Goodness, sorry guys, my stomach's hurting.
and Lori, if you want to do number E.
Okay, so your z-score was 1.07.
Yeah. So Hannah rounded it and she got 1.075. So I'd go with hers.
That would be to the right, correct?
Yes.
Uh-huh.
Let me open an applet. Okay, so the applet would be to the right, just the right.
I see that, Kaylee.
1.07. It would look like this.
Yeah. And then the area.
The area is 0.1412.
That's what I
Yeah.
got. And
Agreed.
then, let's see, Hannah, do you want to do F?
Yeah, so interpret the area. No, I don't know how to interpret. Was this in the lesson? Sorry, I kind of scrambled through the lesson.
No, you're good.
Oh, I don't really know.
So then, Brianna, do you want to do number F?
Interpret the area. So, I mean, I guess that just means that 1.41, that would be the probability, right, that more than 60 phone users in a survey only use cell phones.
Yeah.
Yeah, so the answer key, yeah, it says there is a 0.1416 chance that more than 60 phone users in the survey only use cell phones.
Okay.
So it was saying that, let me see, let me go back to it real quick. Oh yeah, that more than, okay. Okay, so yeah. So then, perfect. Good job, guys. Ready to take the quiz?
Yes.
How are we feeling?
More lost than I thought I would be.
Do we have questions before we do anything? Like, we can definitely go over it right now.
I'm just trying to keep. I don't want to hold you guys up.
No, this
Worry
is
about it.
why we meet in groups, yo.
Yeah. Defeats the purpose.
Okay, we need to clarify. Mean is P equals just whatever they give us is P, right? Is the mean.
Yes.
Yeah.
Okay, in standard deviation, we do it with the standard deviation formula of P hat. And there was another one. The Z formula, that you find the Z score with P hat minus P over square root of P times 1 minus P over N.
For
Oh, yeah,
standard
the Z-score.
deviation, you would just do the bottom half of it, right?
Yeah, the standard deviation's the bottom. Like for the Z-score, right, was what you were just listing off.
Yes, I was doing the Z score.
Yeah. P hat
Okay.
minus P divided by the standard deviation equation. Yeah. Yeah.
Okay, I guess I'm ready.
Ready to go. Okay. As we go over in the quiz too, just holler. Because I did not understand what the heck number 9 was even, so you guys helped me on that. So I appreciate it. So I'm going to start. I'll start it. Alright, and then I'll do number 3, and we'll just kind of go me, Lori, Hannah, Brianna from there.
William,
Number 3.
can you get my
in
charger
a,
downstairs, please? Thank you. I need it quickly.
in a pie chart, why are the slices sectors different sizes? A, pie charts are more visually appealing when the slices are different sizes.
I agree.
Slice represents a category in the area of which slice represents a portion of the total occupied by the category. The size of each slice is random. The size of each slice is determined by the number of categories.
I say B.
So, you say B?
I say B too.
Yeah, I say B as well. So, and then, Lori, do you want to do number 4?
How are bar charts and Pareto charts related? They are identical. They are constructed from, Pareto's charts are Constructed from tossing a coin several times. The only difference between bar chart and Pareto chart is the bars in Pareto charts are ordered largest to smallest, going from left to right. I think it's the.
Perfect.
Which one did you say it was?
The name of the chart because I didn't know the name of the chart. I kept just calling it the P chart.
Yeah, I don't know.
All right, and then Hannah, do you want to do number 5?
Yes. We can put that is normally distributed if n times p is greater than or equal to 10, and that other equation is greater than 10.
I've seen that equation somewhere before.
Yeah, it was in like the requirements.
Yeah. Is P the true proportion?
So that's true. Is p the true proportion or the sample proportion?
True proportion, right? That like related no way to what is this?
Oh, that's it. Also in the summary.
So
Probability cap. Is a P a true proportion of the sample? Did you say true proportion?
I thought it was.
can we?
Yeah.
Okay, I looked back at the notes. It says we can apply the simple limit theorem to a sample proportion and conclude that p hat follows a normal distribution if both of the following conditions are satisfied, and then it lists those formulas. So then it would be the sample proportion.
So P is a sample proportion?
Yeah, I think so.
Okay.
I'm going to put true proportion and see what happens, but it's good. Okay, and then, Hannah, do you want to do number 6?
Yeah, you want me to go again?
Oh, did you go or did, wait, did Lori do number,
I didn't do it.
Okay.
I did.
Hannah, do you want to do number 6? Why do I keep doing that, guys?
Me? Okay, I'll do it.
Yeah.
What is N? I think it's the sample size, right?
I like that question.
Yeah, I like those too.
Okay, and then number 7, if P equals 1/4 or 0.25, what is the smallest n has to be greater or equal to 10?
Okay, so we would just do
So
N times 0.25, right? But wait, how would you do that?
Or you do the formula NP greater than or equal to 10?
Yes, I think you just have to plug in numbers, I guess.
So yeah, so I took 0.25 and I divided 10 by 0.25.
Uh-huh.
And that gave me 40. And so then just to do the algebra for that again, I took 40 times 0.25 and it equaled 10.
I'm going to
So
write that down because that's a really good strategy.
Oh, thanks. But yeah, so the smallest that n could be is 40 to satisfy the requirement.
Coolio. I'm just forgetting all of my algebra. It's so crazy.
That's not good.
Hey, and sorry, for number 3, did you guys put the second one down?
Yeah, we did.
Oh, you did? Oh. Hang on a second. Okay.
Yes.
Yeah.
3 we put B.
Oh, okay, yeah, I did.
Okay. And then, Lori, do you want to do number 8 when you're ready?
Okay. Okay. Use the following information to answer questions 8 and 9. Suppose n equals 24 and p equals 0.4. What is the mean of p hats? The formula would be in the in the remember area. P hat is equals x over n. So you would take n, and put it on the bottom. So you'd have 0.4 divided by 24, and that would be 0.6. I'm just estimating.
Is this the one though that we're supposed to like just say, because like P, like the mean of P is the same as the population P, or is that a different one?
Right. That's why I'm confused.
Yeah. I'm confused because they don't give us an X.
Yeah.
So that's why I'm like, okay.
Is P the X?
No. Let's see.
Yeah, in the notes it says mean of P hat equals P.
So it would be 1/4.
Yeah, I think.
No, it would be 0.4.
Yeah.
Yeah.
Okay.
I was reading the wrong numbers. 0.4.
There's a lot of
The
numbers.
standard deviation is the square root problem with P times 1 minus P over N.
Yep.
So P is 0.4 times 1 minus P over
Let me know what you guys think.
0.4. One. 0.6 times 0.4 is 24, isn't it?
0.6 times. I don't know. 0.6.
0.24. 0.24.
0.24. Yeah.
24. Square root of that is 0.1. Is that what you guys got?
That's what I got.
Yep. I got 0.1. Perfect.
Nailed it.
Did it.
Okay, we've got 7 more problems.
Woo.
Yikes.
8.
Here we go. Here we go. We got it, guys.
Okay, is it my turn?
Yeah, somebody's turn.
So, number 10, use the following information to answer questions 10 through 13. Brittany's batting average is 0.3. We want to determine the probability she will get more than 35 hits in her next 100 at-bats. So, what is P hat? So, is this when we do x over n? So, it would be 35 divided by 100?
Yeah.
Right?
35 divided by 100.
So, it's
Wait a second. So. Do we have to subtract something from 35 or?
For the standard deviation?
Oh, we're getting this. Wait, which one are we on? Did we do number 10?
I thought we were working on 10. Is it 0.35 or is it 0.3?
0.35 is the
0.3.
hat. Yeah.
Okay.
Standard deviation. So we do the square root problem again.
Yeah. I can make sure to square it, guys. Don't worry. You can do it.
So why is number 10 not 0.3?
Because it's p hat and it's x divided by n, which x is 35.
Oh, I always forget to do that.
No, you're,
Okay.
you're good.
Okay.
1 minus.
And what was the answer?
0.35.
0.35? Okay.
Okay, so we set it up. The next problem. What is the standard deviation of square root of p? Of p hat. Set it up 0.3 times 1 minus 0.3 over 35, and the square root of that. Is that correct?
Yes, that's correct.
N is 100, right?
Yep, n is 100.
Why is n 100?
Because that's the
N is 100 because that's the total population. That's the total sample.
35 was x. What we used for x.
Okay.
Oh, yeah.
Over 100.
I hear a baby.
You want to see the baby? My husband wants to see your baby.
Oh, okay.
Isn't she
Really
cute?
cute.
You can't resist.
You pooped all over me today. This is in your future.
Yeah, it's true.
Fun stuff.
Oh goodness, you're excited. Yeah.
Okay, so it's the standard deviation. Did you guys get 0.04546?
Yeah,
Yeah.
that's what I got.
Okay. Z-score. We have
So cute.
okay, p hat is 0.35, and p is 35?
Is
P is 0.3.
P is 0.3. Oh, okay, never mind. N is 100.
I have such bad heartburn.
Z-score.
That's no fun.
Yeah.
I get that all the time.
No, I don't usually get it, but now I do. Alright.
So for the z-score, guys, did you get 1.08?
Did you say 87?
Yeah,
1.087?
yeah. I just rounded up one.
Yeah. That's what I got.
Okay. Awesome.
1.087.
Mm-hmm. That's right.
Probability she gets
Yeah,
30.
now what's the probability she gets at least 35 hits in the next 100 at that graph?
Wasn't that what we did for p-hat? So that's 0.35.
0.35. No, the probability is when you use the normal probability applet and type it in, and then find the area towards the.
Oh, so you did the Z-score?
Yeah, so using the z-score 1.087, you plug it in, and then you'll find the area. I assume that it's just looking at the right side.
Mm-hmm.
I got 0.1385.
Yeah, that's what I got. So,
Yeah.
So 0.139.
3.5.
Yeah,
We
0.139.
went into 3 decimal places.
Yes. Yeah, the 5 at the end.
All right. I'll read number 14. If the true proportion of people who support a political candidate is P equals 0.52, and if N equals 2,000 people are surveyed, we want to determine the probability that the results of the survey will suggest the candidate is losing the election, getting less than 50% of the votes. What is the standard deviation of P hat?
I'll be right back.
Okay. So, and guys, by the way, I wanted to mention, so number 14, it said if the true proportion of people who support a political candidate is P equals 0.052.
Okay, so back is it earlier? Yeah.
Number 5 is the true proportion. So,
Okay.
they gave us an answer, guys. Haha.
Love it when you do. That's why I always go back, because I'm like, I'm not going to figure it out now. I'm just going to go through the rest of the text.
I'm surprised I even remembered that. I just
Good thinking.
So, but for this equation though, we wouldn't need to know what p hat is. We would just need to know p and n, and then calculate that in with the square root equation.
Okay. Got it.
Which one are you guys on?
We're on
The
number
same
14, and we're figuring out just the standard deviation of p hat with the variables in that question.
Did you tell Lori about number 5?
Oh, and Lori,
Let's change
so in the question 14, it says
Uh-huh.
if the true proportion of people who support a political candidate is P equals 0.52. So it starts out with that. In number 5, the question was, is P the true proportion or the sample proportion? And it gives us the answer in number 14. So it says true proportion. So just make sure to change that before you submit it.
I didn't put anything actually.
Oh! Good we found it then.
Yeah, thank you.
You're welcome. Yeah.
Okay, so let's see. Square root. We take 0.52. And it is 2,000. Right.
Yep. And
You guys don't have to wait for me if you don't.
Yes.
so
My dinner was burning.
but I did get 0.011, if that's
Yeah, I
what you got as well. And then Lori, just let us know if you get the exact same thing too. No. Dinner's pretty important, if I do say so myself.
Yeah, my husband thinks so too.
Yeah,
Especially
your husband's
on
like,
the grill.
Yeah. All right. Um. Yeah. If after that though, Hannah, do you want to do 15 or?
Yeah.
Okay.
So what would you use? So that's the p hat minus p over the standard deviation. Do we have the p hat?
So yeah, because like the p hat, I'm assuming that it's like 0.5 is p hat. Because they want to know if what the probability of the guy getting less than 50%. So we could do like
50.
0.5 or 0.49.
That's what I was thinking too.
Yeah. So, the
So
z-score
it'll
would
be 0.5 and 0.52 all over 0.011.
Mhm.
yeah.
I messed that one up. Okay.
So, but just in case, would we do 0.5 or would, since it says getting less than 50%, would we do 0.49?
Tough one. In the examples I saw, they just did 0.5.
Okay.
But yeah.
I'll go with that then. If the examples.
0.52 divided by 0.011. You get 47.272.
For
Um,
50.
That would be way too high for a z-score.
I got negative 1.818.
yeah, negative 1.818 is what I got too. So, negative 1.0818. And,
So
Brianna,
for p hat, you got 50.52.
so we got p hat is 0.5, and so the equation would be 0.5 minus 0.52 divided by 0.011.
Okay, that's where I messed up.
Let's see, because then negative 1 point. And then yeah, Brianna, if you want to do number, what was it? 16. Thank you.
All right. What probability do you compute using the normal probability applet? At first I didn't really get it, but I chose the first one. What do you guys think?
That's yeah. Just looking at it, I think it's the first one, maybe.
Yeah.
Yeah.
Yeah,
it's
it
yeah.
is.
And then, Lori, do you want to do number 17?
What's the probability the survey results will show the candidate is losing even though the true p equals 0.52? That I don't know how to probability.
So, you put in the z-score into the normal probability applet and find what's to the left.
Okay, so you find out. Okay, you put the z-score of negative 1.818. Okay, I will have it in a minute.
And you said you shaded the left of it?
Yeah,
Yeah.
because what's the probability of him getting less than 50%
Oh, right.
of the votes?
It'd probably come out with the same answer anyway. So let's see. Let's see. Yeah.
0.1385. Is that the same answer? I don't know.
I got 0.0345.
That's what I got, 0.0345.
Oh, Sorry, guys, I put the wrong numbers in.
Yeah,
That's
that
okay.
happened.
So it was 0.035 though, guys, right, when you round it up?
Yeah.
Okay. All right, I'm going to submit it. I'm going to do it.
You want me to do it first?
Oh,
0,
Did we
3.
get it?
Let's see. Okay, so
No!
numbers. Oh, darn.
But that's the odd thing. It's like we got that Z-score.
How did we get 17 right and 15 wrong?
That is really odd. But so, and the other thing too that I was wondering when we were looking at like number 16 is like, is Z the Z-score of like the population? Like of just regular P, and then Z, the little z is like P hat Z-score?
I know what we did wrong.
What?
We were supposed to. Oh wait, that doesn't make. No, I don't understand it. Never mind.
Yeah.
I thought I was smart.
So 16 is wrong? I didn't get 16 right.
You didn't get it? You got it right?
No, I didn't turn it in yet.
Okay. Watch out for 16. Whatever we said is right, it's wrong. Oh man.
But if you feel like going down with us, feel free.
Did you guys get 15 right?
No.
No, 15. We didn't get right.
Oh, okay. I'll go back and work on it. That's weird.
Yeah, no, I'm not.
Email him. I don't know why I got that one wrong.
But I can email him or like ask just on the. Yeah, I'll email him because then if I send it via the notes from instructor, then other people can see the answer.
Oh yeah, that's true.
Bad idea. Oh, okay. And but before we go for this though, guys, we do need to talk about our project ideas. I do have the Word document for like step 1 through 7 and like what parts we're gonna do. So for the group project, there will be 2 people who do 2 things, and then there will be 2 people who just do 1 thing, and then everyone will do step 7.
Okay.
Okay. But just depending, like, I don't know if you guys gotten a chance to look at it. Does anyone have something specific that they want to do? Is there anyone who wants to do 2?
I mean, I can do 2. It doesn't really bother me too much.
Or actually, wait, hold on. Or there will only be 1 person who does 2. Sorry.
I'm just thinking some of those projects, how are you going to get the data for them?
Right.
To conduct it.
I don't know. I was looking at like other ideas too, and I was like, whoa.
Because I could see if you got the data for like Wall Street, when the market goes up and down, I could see you finding that data, or you get candy and compare it to other candy, but those surveys of GPAs versus, you'd have to go and take a survey, wouldn't you?
That's the fun part.
Or guys, we could do our Skittle colors equally distributed.
Yes, that's a good one. Just buy a bag of
As long
Skittles.
as we get to eat them.
And then you can eat them, yeah.
I do have Skittles. What are the odds?
Any project where we can eat it afterwards.
What's that?
I said I'm down to do any project where we can eat it afterwards.
Yeah, I know. I was kidding.
Like,
There was also the cereals, the sugar comparison. That was fun.
Oh yeah, that's true.
wait,
Does he have a list of stuff we can do somewhere? Or is this stuff we're just making up?
Some extra ones today, but there were some the other day. Do we have to decide on that part now?
say that again.
Do we have to decide on that part before Wednesday? Well,
Um,
collect the data on.
yeah, I think that is one thing. Let me go back to it really quick. I don't know
Yeah.
if that's an overview.
I'm so confused with that. I'm still thinking about the quiz. I'm just really dumbfounded.
So, yeah, he wants us to have like a firm idea of what we're doing before Wednesday and like who's doing what too.
Let me look at it.
I just think that would be the hardest part.
Good, get it done.
I'm willing to do it, but it's the hardest part.
Yeah.
It will take, and luckily we send in different things each week. So we'll send in one thing each week. And we collaborate by like we can help each other with it just by like sending each other the documents and saying, okay, does this look okay? And then just making sure to edit it if it needs editing.
Notes from instructor said that he gives us 2 different samples of things to work on for the statistics for the final project. And then I saw something, maybe original final group project, that said things that you can look up.
So what you're saying is like the project ideas?
Yes.
Okay.
I would
Okay, so
be
then
more happy with something you could either get the information off the internet or you go to the store and get the food and compare it. That's just my opinion.
Yeah, I don't really want to have to go interview a bunch of people on a college campus or anything.
I like the Skittles idea best. Or guys, I love this one, okay? Who has the best deal on French fries? And I am willing to go and see who has the best deal on French fries.
Oh yeah, I saw that one.
Speaking of pregnant woman's language over here.
But for like, do you guys just want me to do 2 parts and then you each can choose one part that you want to be the main writer for?
Yeah. Yeah, because it looked like there's like only 5 parts that can be main writers for, and one was a PowerPoint. So like we could even just do that on Google Docs at first, just to have everyone contribute if you want.
Oh, for the PowerPoint? Just have everyone contribute?
Yeah, I think because if you do it on Google Docs, you can just, and then I don't know, I guess there would be one person that has to like combine it, but it's a little bit easier that way.
Oh, yeah, well, specifically, so starting with Lori, do you have one that you would prefer to do, like to be the main writer for?
Describe the data.
Okay, I'll put you down. All right, and then
Take action.
and then Hannah, do you have one?
Oh, I don't care which one. Let's see what I pick again. I can do any of them.
Okay.
I can help you collect data.
I think, well, everyone's supposed to collect the data, I think, right? Is that right?
Yeah, everyone is supposed to.
Okay.
So, let's see. Brianna, do you have a specific one you would like to do?
Let me think. All right. I guess I could take action.
Take action? Okay.
Yeah, I'd be fine with that.
All right, and then, wow.
Describe the data is probably the one that no one will want, so I can take that one.
I think Lori actually wanted it.
Yeah, Lori just took that one. Sorry.
One man's trash, another man's treasure.
Number 4. Nobody take number 4 yet, did they?
I don't think so. Make an inference.
Yeah, Hannah, do you want to be main writer for designing the study?
Well, I'm not gonna. I can take. I don't want to leave you stuck with 2 and then have like one that's a lot of work. So I can do describe the data. That's fine. Because well, is describe the data. Am I like not thinking right? Is that one really easy, or that one? Will
Lori has that one.
Wait, what?
Lori took describe the data.
I thought she has design study.
Wait, which one do you have, Lori?
I thought it was 3.
Yeah, she's
Oh, I thought.
the data. So like.
Oh, never mind.
You can
Sorry, I'm
take
trying to
step
take the
1,
job.
step 4, step 6.
Sorry, what?
Oh, so like the options are step 1, step 4, or step 6 for up for grabs right now.
Okay, I don't know, 1, I guess. That one is easy.
Okay. Okay, so you're in charge in choosing whether or not we do French fries or Skittles.
Oh, that's a big deal.
Skittles!
Skittles.
And then I'll do make inference as well as yeah, we can work on the PowerPoint presentation, but I'll put it all together.
Okay, sounds good.
We can help you with the pieces and you'll make it nice.
Yeah.
Yeah. Perfect. Okay. So Hannah, so are we gonna do Skittles then? Have you?
Yes.
Okay. We're gonna do Skittles. I'll write that on top. And then Skittles taste the rainbow. And then design how we're gonna do it, and then we'll do it.
Okay, I'll get back to you. We're meeting Thursday at 6:30.
Thursday at 6:30. Yep.
Okay, cool.
Okay. All right, ladies. Well, thanks for a good night.
Thank you.
All right.
Good night.
Bye.